guys, this is Mr. Meller. Our lecture on linear motion begins. So today we're going to be looking at speed versus velocity. Speed is a concept that has given historical scientists a really hard time. It wasn't until the 1600s when we had our friend Galileo came up the first way of measuring speed. Right? Previously, we had had qualitative measurements of speed, faster or slower. Galileo came up with the average speed of an object is equal to the distance that object covers divided by the time interval it takes to cover it. All right? So speed is how fast an object is moving, and we can measure the average speed with this equation. All right? So we have two main ways of describing speed. One is instantaneous speed, and the second is average speed. All right, so imagine you're driving down the highway, life is good, maybe you're going to get a hamburger, maybe a cheeseburger, maybe a burrito, right? You're going 75 miles per hour, and then yikes, maybe you see a cop, right? And so you slow down to a little bit below the speed limit, 68, right? And you've just changed your instantaneous speed. In fact, you went from an instantaneous speed of 68 or 75 miles per hour, 1 second, split second later, 68, all right? And then you have your average speed. Say you are concerned with your fuel economy. Your average speed is the total distance you cover over a trip divided by the time that trip takes. So if you're concerned with, say, your fuel economy, you're going to go ahead and care about your average speed, all right? Speedometers in cars will show instantaneous speeds, the speed at any given instant. All right. So very quick check question. What do you think a cop would care about? Would he care about average or instantaneous speed? Go ahead and answer. He would care about instantaneous speed, right? 75 miles per hour, no good, right? Please lower that down to 68 miles per hour. Okay. Speed at any given instant. All right, and so as we saw, speed is highly dependent on distance, right? It's actually, if you look at the units we have, it's a length over time. So we actually have, again, two ways of describing something that are very similar. We have distance and displacement. And displacement is going to have to do with velocity, which is speed with direction. We'll get there in a minute. Distance, as a term we use all the time, is actually equal to the total length that an object travels during a time period. All right? Direction doesn't matter when we're referring to distance. Say you're walking to school. You start at A, that's your house. You end up at B, and you take this long, curvy path. You've walked 5.2 miles on this. Man, you are a trooper. Good job. We could describe your same trip, though, with displacement. We would say, all right, well, our friend actually went from point A to point B, and that same trip, their overall displacement, the shortest distance between their starting point and ending point, was actually 3.1 miles, and they went north. So did you go 5.2 miles, or did you go 3.1 miles northeast? Well, both are true depending on how you're describing the situation. Your total distance covered was 5.2. The total displacement, the length between your starting and ending point, the shortest length with the direction, was 3.1 miles northeast. So displacement is the shortest length between the starting point and the ending point of an object. All right, we're going to come back to this example in class. So what if we were to go ahead and apply Galileo's equation, average speed equals distance over time? Let's just take a look at a couple of practice problems. Question 1 says, what is the average speed of a biker who travels 10 meters in 2 seconds? Remember, it took us until the 1600s to be able to get this equation. Wow, it seems simple to us. We've heard it since maybe elementary school, but can you believe it? Science is not always so easy, right? So what's the average speed of a biker that travels 10 meters in 2 seconds? Go ahead and try that on your screen. Speed is equal to distance over time, so we have 10 meters over 2 seconds, and we get 5 meters per second. All right, who knew that could be so exciting? All right, and question 2 says, how far does a biker go in 10 seconds if he's moving at 3 meters per second? Go ahead and try that one on your screen as well. use one of our three equations. All right, the answer is 3 meters per second, our speed, our average speed, times the time interval, 10 seconds. We get 30 meters, right? Distance is equal to average speed times time. Question 3, how long does it take for a biker to travel 100 meters if she is going 5 meters per second? Well, use our third form of the same equation. Time to travel is equal to distance covered over average speed. Go ahead and try that on your screen. All right, 100 meters divided by 5 meters per second. We're going to see our meters cancel, and we're left with 20 seconds. It takes her 20 seconds to go 100 meters. All right. So we have one more term, which is velocity. Velocity is, at its core, speed with direction. All right. Very quickly, why would that matter? Say you're in the Indiana Jones movie where he's getting chased by a boulder. You are Indiana Jones in this case. Right, the boulder's on this side. Okay. And you are moving as Indiana Jones at 15 meters per second, and you're going north. Right? The boulder, unfortunately, is going 20 meters per second, and it's also going north. Right? It's going faster than you. It's going in the same direction. You're going to get squished. Yikes. But the situation's a bit different, right? If the boulder instead hits something and now it's going 15 meters per second or 20 meters per second south, right? Then suddenly, life is good. We get a little smile on our face, right? So specifying direction in physics is hugely important. In fact, you could say it's life-saving, right? So velocity is how fast an object's going and the direction it's going in. In fact, if we were to calculate average velocity, we'd use displacement divided by time. Speed is just distance divided by time, all right? One last thing, if you were to change your speed of a car, you would step on the brakes or the gas pedal. If you were to change your velocity, because velocity speeds direction, you could do the exact same thing, but you could also turn your steering wheel to change the velocity, because steering wheel changes direction, and velocity is speed with direction. All right, that's it for now. See you guys later.